Alright, time for another DraftPhysics.com video presentation. So, more comments related to the conversation on one of physicist Michael's videos regarding relativity, which gets to the subject of whether there is a necessity based on the kinetic energy formula to actually use 4 times the fuel to go twice as fast. Or can you hide that necessity by claiming you're using the same amount of fuel but you're just getting more or less out of it, some kind of argument like that. I'd say the arguments are all defeated if you're using, say, a pressurized gas as the fuel, but whatever. It just doesn't work. It doesn't make any sense, blah, 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 blah. But we've been over all those arguments, and frankly, what good is it? All right, so this techno whatever whatever, anyway, him, who started the conversation in the sense that he posed a question to Physics Michael, and Physics Michael paid attention to it for whatever reason instead of doing his lever experiment. But anyway, and look, this all comes down to, I'll ask this tech guy, do you understand? Okay, the history is based on Leibniz, okay, who opposed what Newton had argued before Newton argued it. So a year before Newton published, Leibniz published for the first time the argument, he believed it for a while, of mv squared. Okay, so it wasn't 1/2 mv squared, just mv squared, and it was his definition of what energy was in the universe as opposed to everybody else's understanding that momentum. So he's really opposed to Descartes. So Leibniz didn't think much of Descartes, just the truth. What the hell is going on? Anyway, okay, I gotta find this one, get rid of that, get it out of the way. All right. And so this all comes down to an understanding of gravity. So as I have pointed out, so tech guy, do you understand it's 9.8 meters and the ratio is 9.8 to 1. 1 second. 1 second. 9.8 meters. Okay? 9.8 meters, 1 second. That's the actual definition of what gravity does. So every second it gives you a certain amount of energy. And that's it. And so it's so simple to understand that, yes, you drop something from 1 unit of distance, okay, it travels 4.9 meters, okay, in 1 second, okay, but it has a velocity of 9.8. All right, and so just logically you can understand, well, yes, if you go 4 times higher with the same object, the fact is that as it falls, okay, it's going to be going faster than this was going. A lot faster for a lot of the time. Okay, for this little bit of time, it's going to go 9.8, where this one, obviously, if it only went 4.9, its average velocity is much less than 9.8. So this one's going to be going 9.8 a lot, and this one's not. And this is just 2 seconds, right? This is 1 second, this is the second. So, as Newton pointed out, okay, yes, this is 4 times the distance, all right, but it's only twice the time. It's only 2x the time that it's being pushed by the gravity. And as I pointed out, do you understand that if I fly by a planet, and I'm going to fly by this distance by the planet, that the faster I go, the less I'm bent? Clearly providing a pretty convincing argument that speed has something to do with it, that the amount of time you're exposed to whatever the force of gravity is, so who cares what it is, but the fact is that what changes as I go faster? Well, the amount of time I'm in it. So like a sunburn, if I go outside for a very short period of time, I don't get much sunburn, but if I go really slow, well, then I get burned a lot. So it's like any other heat equation, or it's so simple and so obvious that it's the amount of time that decides how much force you collect, how much force the gravity imposes on you. And so it's twice the time, it's only going to be twice the velocity, and I'm arguing certainly that's only twice the weight when you hit the ground. And that's all you're going to get. Okay, so you do this experiment, and that's how it's going to come out. This will be twice the weight on a scale that this was. for the same mass object. Now that's been verified by retards. Can't really trust retards because they say other things that are really retarded. I mean, sometimes even a retard, gets one of the words right. But anyway, so that's the context. So all of this is just a misunderstanding of the gravity. Leibniz saw this 4 distance thing and said, yes, it's 1, 2, 3, 4 units of gravity. When no, it's only 2 units of gravity because it's every second you get this. You don't get it every foot or every meter. You get it every second. And it's only 2 seconds. This is 1 second. This is 2 seconds for this 4 thing. There, that's the argument. Now that's the argument I'd like you to say, okay, I think there's a huge flaw in that argument somewhere, and there's some hope for this kinetic energy theory. But there really isn't any hope for it. It's wrong right from its origin. Right from its origin, it was wrong. It's always been wrong. It's always never done anything that needed to be done. There was nothing broken in Newton's mechanics. That's why Newton was buried as a god. It's because his mechanics worked really well, and it made accurate predictions, as they keep saying. So they do a couple of chicanery experiments. I've pointed it out. I mean, the clay experiments, dropping the round things into clay, stupid idea. I could argue that these new experiments they're doing with their little floating carts all have flaws in them. They don't get perfectly accurate data. And if they do, you should be very suspicious, frankly, if it's making extra momentum. So the physics Michael guy did an experiment where I'll just point it out again. Do you really think this happens in reality? Do you think it's possible? Or take the same explosive device, the same amount of force, the same little bits of photons are going to come off of it, the same amount of heat and little fragments and little pieces are going to come off of the explosion. So I have exactly the same explosion, exactly the same explosion, exactly the same explosion, exactly the same explosion. Okay, and so I put a 100 mass, and let's just say it gets 100 momentums this way and this way because it's an explosion. All right, now I put a 200 mass, and I get 200 this way and 200 this way. And I put a 400 mass, and I get 400 this way and 400 this way. This is the experiment he did. Okay, I mean, he didn't do these extra bits. He just did this bit. But yeah, you have a total of momentum, total of little bits hitting shit, pushing stuff in the universe of 200, and then you have 400, right? And then you're gonna, and then you're gonna have 800, okay, and then you're gonna have 1200, right? Something like that. No, 500 and 500 would be 1000. All right, do you think that happens? Do you think this is a realistic, that I can go both ways here? I can go 50, okay? It gets weaker and weaker. So the lighter thing I put in front of the explosion, the less momentum I get. So I'm gonna get 100, and I could go 25. I get less and less and less. Do you think that really happens? I put lighter and lighter things in front of the explosive device, and I lose more and more momentum, total momentum. And clearly it's total momentum. Clearly there's no opposing momentums, like somehow you could say the momentum's canceled out. Explosions don't cancel anything out. They blow your fucking face off. Okay, it doesn't blow somebody else's face off on the other side and therefore it didn't happen. No, there's 2 faces that are blown off. So it's just absolute nonsense to say the total energy or power or work capacity of the explosion isn't adding this to adding that. Of course, you're adding all these arrows. All these arrows are its energy, all of them. You don't cancel them out and say it has 0 momentum. It has 0 energy. Come on. So does that experiment have any credibility, can you say? I mean, on its face, does it make any sense at all? Because it's doing exactly the opposite of the gun, by the way, right? So if I make a zip gun, I mean, I've made these arguments, and it's just a little bit annoying that, why don't you just say that, yeah, that zip gun argument's hard to deny. How can we play this game that I can create different amounts of energy out of a circumstance by, these simple little changes? So I make a zip gun, and I put 2 bullets in, same charge, same explosion. And then I make a zip gun where I put 2 big, heavy, gigantic things, 2 guns, okay? I make a zip gun, all right? Same exact explosion, I put a gun, I put a gun inside the gun, Okay, so there's a gun in here and there's a gun in here with a solid barrel. All right. So what they're going to say is I get 4 joules of energy here, and I get 4,000 joules here. Same exact explosion, contained in the same container, 4,000 joules of energy here, 4 joules of energy here. Come on. Too frickin' silly. Yeah, it's the same momentum. So again, let's just understand, momentum is just fine because this is 1,000 more atoms here than there is here. 1,000 times more atoms. Okay, so yeah, it goes 1,000 times slower. Okay, but it's 1,000 times more atoms. So momentum says everything's just fine here. No problem. Same momentum here, same momentum here, same momentum here, same momentum here. Explosions work just fine. But kinetic energy makes an insane mess out of it. Alright, so context again. I have to keep doing this context thing. Alright. So, I'm a little, I find this guy a little tedious just because I'll read the comment he left on physicist Michael's page, which is essentially just saying, oh, I give up, everything's fine, thank you very much. I totally understand what you're saying. Yeah. I downloaded a book called Fundamentals of Astrophysics and Applications. Yeah, so I went to the trouble to go find it and download it. And it talks about every single thing about astrophysics. Okay, it talks about planet orbits, all kinds of other crap. It doesn't, you have to sit there and isolate where you're saying this kinetic energy thing comes up. And it mentions kinetic energy. Well, where does it do that exactly? And it makes use of it in several calculations. About what exactly? I don't think it's going to be about what a thruster does in space. So, I mean, clearly I've made the argument that thrust in space, that is, if you're going to use this idea of throwing something out of your ship, off of your ship's premises, that it's always momentum that'll decide how much it's going to affect you. It's a momentum exchange. Can I ask you, why do you believe NASA doesn't treat it as if it's real? I've made the claims before. I mean, NASA doesn't say we use Newtonian physics for no reason, because they're basically trying to explain that no, they don't bother with relativity, and they certainly don't bother with Leibniz either when it comes to navigating in space. Okay, so I did some research on the computers that run the lunar module, and I can't find exactly specifically, nobody explicitly says 1/2 mv squared wasn't in the computer, but there's every indication that the math formulas that were in the computer were just momentum formulas. Okay, honest question. Well, whatever. Anyway, to sympathize, I mean, I'm a little annoyed that KE feels elusive in the way that that's hard for me to put my finger on. Well, it should be easy to put your finger on, since I've told you the history. There's no experiments. The only experiments they had were these little ones, these little kind of fakey experiments, where you drop just round things into clay, and then you bang things into a surface and knock things off the surface and count how far they go rather than how many go. So instead of counting how much energy was total energy, you're just taking, well, the faster it makes it leave, therefore it has more energy. I mean, these are all dissectable experiments as being, fake. I mean, they're going to give you a false impression. I've explained how friction works on a linear surface and said that it's kind of obvious that it's a huge giveaway that it isn't going half the speed till it's 3/4 down the track. Obviously, the friction isn't linear. Okay, it's as if it's shy for purposes of falsifiability. No, it's as if nobody did the frickin' experiment. So again, the falsifiability is right in front of our face. So the Eddington experiment done from space, completely falsifiable. We could falsify the twice as bending of photons tomorrow. Okay, it would take 5 minutes and they won't do the experiment. Okay, so let's just be clear. They haven't done any of these experiments. They have not, gone onto a pool table or done Newton's cradle. They haven't itemized exactly what happens when they use different weights and with different velocities. They haven't done any of that itemization of their physics. Okay, they've evaded falsifiability because they haven't done the simple experiments, and they're so damn simple. Okay, it's as if momentum has a sort of metaphysical, so I don't know why you would even use that word and think it would appeal to me. Momentum is not metaphysical. That one's the one that's unmetaphysical. That's the one that is so fucking in your face physical. Okay, it has nothing to do with metaphysics or woo or spirituality or any of that horse shit. Momentum is the dirt, simple, rude, raw. You can't get more real than like a tree. Okay, it's a tree. It's not some, fluffy thing. And KE conveniently molds itself to fit the circumstances. Frankly, you say it does any of that. I say it's completely not consistent with anything I understand. I do not believe it takes 9 times the fuel to go 3 times as fast. I think it's absolute preposterous nonsense. I don't think 8-pound bowling balls going twice as fast knock down twice as many pins. I think it's absolute crap. So your description of the circumstance is upside down from my perspective. Everything rock solid is momentum. Everything wooey and speculative is KE. Okay, and everything marginal, in some tiny little isolated experiment, they'll get a result they like, and then they'll go with it. That's how it feels, although I know feelings aren't necessarily truth. Well, I don't understand the feeling part anyway. I'm hoping that by working through the math myself, so I don't know why you would work through it. There's nothing to work through. It's a formula. You either say it's accurate or it's inaccurate. You either find evidence to support it or not support it. But you can't do anything with it. The math isn't going to solve the problem. And certainly the idiotic notion that you can combine both things and say they're equal to each other, that's what they actually do with their math, is they go 1/2 mv squared equals mv. And then they derive an equation out of that slop. Okay, it's my own time. I'll click more, whatever that means. All right, so Farley, Dick Woodman, obviously Dick Headman. But anyway, falsifiable question mark. It makes accurate predictions. So about what exactly does it accurately predict? You can't even tell me one way or the other whether it takes 4 times the fuel to go twice as fast. You can't even tell me the answer to that question with any authority. Okay, and you're telling me you're predicting something? What the fuck are you predicting? Okay, Michael did an experiment showing that to draft. He did an experiment that's just complete crap from on its face. I'm just saying, it's an experiment that says I can make free momentum. I just put heavy things in front of an explosive and I make more momentum. It's a nonsense experiment. Consider, say, 2 objects about to slam into each other, and one of them has a mass of 5 and a velocity of 10. Well, why don't you just do the combining experiment? We've already talked about it. Now, why don't you just have the 5-ton train combine with the 5-ton train that's not moving and become a 10-ton train going half the speed, and then explain where half the energy went, and that you lost half the energy without losing any momentum. So without sacrificing any momentum, you somehow did a bunch of work. You did a bunch of things. Things flew off and sounds were made and vibrations went into the ground and all kinds of stuff happened. And yet you didn't lose any momentum to do all of that. To create that heat and that movement and that energy, you didn't use any momentum. Explain how that's possible in this universe. And the other mass is 10 going 5. Who cares? The net momentum is 0. So again, this is just baby talk, this net momentum horse shit. Okay? And it's not applicable to any of these explosion experiments. It's just nonsense to sit there and say an explosion is a 0 momentum event. Again, I made the joke. What, should we let the Unabomber out of jail because he couldn't have been doing anything dangerous because all he did was put 0 momentum devices into the world? What can a 0 momentum device do? It's just too fucking stupid. So the momentum after the collision is net 0. What will the final velocities of the objects be? Right, is that the part you're predicting? Are you actually predicting that I can make less and less energy, according to physicist Michael, and yet I make more and more energy with an explosion? So I use a spring and I get less and less if I go lighter, and I use an explosive and I get more and more if I go lighter. It's just nonsense. Problem is you can't know without knowing KE. One solution might be the 5 masses going minus 10 and the 10 masses going 5. Another solution, well, I forget it. We just won't bother with all that. Let's do these thought experiments in our head. Fuck you. There are too many ways to satisfy momentum conservation, so it begs the question, where's the momentum conversation when you can have 4,000 joules or 4 joules? Where are you conserving anything realistically? It doesn't make any sense. What it's about, the universe makes it a particular outcome. The missing info is KE. So again, this is whatever. This is just mush. You're not saying anything real. I mean, there's real circumstances. You're saying that these circumstances, you don't have to use extra force to create extra kinetic energy. And then there's other circumstances where you're pretending you can make free momentum and it's okay. I can have 100 momentums going this way. I can do an experiment and get 133 going this way and everything's just fine. And I could do that experiment to its maximum and get 2. I could double my speed. I mean, my momentum. I could double the momentum just by doing the experiment differently. With KE and momentum, you've got 2 equations for each variable. So this is just more nonsense about how they convolute the mathematics to force things to come out their way rather than actually do the mathematics. So if they actually put the numbers in and do the equation before they derive it, they'll get an answer. Then after they're derive the equation, if they solve it then, they'll get a different answer. That means you did something wrong. The 2 answers should agree with each other. With just momentum, it's not solvable because we don't know enough about the system. But what if we did know? We have all the answers, we put the answers in, and we get an answer. Shouldn't your derived equations come up with the same answer? Well, they don't. Let's see. Remember, KE is work, which is, again, nonsense. Work is a useless word in physics. Okay, work just means the energy I like, and everything else is waste. Okay, so, but that's all it means. It doesn't mean anything real. The waste and the work are all the same thing. It's heat is energy. Heat you like is energy. Heat you don't like. Okay, heat in the wrong place is still work. It's just nonsense. Okay, when objects slam together, there's work done on each other, says you. The Newton's cradle proves pretty decisively that there's very little work done. That you conserve the momentum. That is the energy. That's everything. You could just Newton's cradle, Newton's cradle, Newton's cradle. It doesn't matter. You could put 10 balls in the way and it just goes right through them all. Forces get applied over very tiny distances, so some more nonsense. Very tiny time interval. So what? Again, doesn't mean anything. Which means the amount of force spikes in that moment of collision, says you. There's just going to be a conversion. Okay, one thing's moving and the other thing either resists the movements because it's too heavy, in the sense that it can't absorb it, or it's too light and it can't take all of it. But that's all there's going to be is a conversion problem. That's why I've brought up the levers, because it does the converting. Okay, the dynamics of that work is where KE is involved. It has to be that way. Makes sense. You can accurately predict experiments. What experiments have you accurately predicted? So show me the list of those. You can't even tell me how much gas it takes, okay, to go from 20 miles an hour to 30 miles an hour. You can't predict that one accurately. Okay, Dickwood. No, I haven't closely watching anyone's art engagements. Well, you really should be, since you started the engagement, and the guy made 2 videos based on what you started. What you said vaguely reminds me of the physics problem I had to solve in high school, so thanks for reminding me of that. I don't know what it reminds you of, but anyway. I appreciate the emphasis on the meaning of energy in terms of work. Why would you appreciate that? The word work really can't mean anything to anybody sensible. What can it possibly mean to you? We call the part we want work. We call the part we don't want something else. It's obviously the same stuff. It's crap moving. It's just too ridiculous. I think that's probably a useful angle to keep revisiting. No, it isn't. And yes, it does make sense. I'm sorry it makes sense to you. I pity your poor brain. I might have worded it poorly. I'm just trying to find common ground with DraftScience. There's no common ground. So again, this is just such nonsense. You think this is a semantics argument, huh? I mean, they're two completely different descriptions of how the frickin' thing called movement in the universe is exchanged between objects. Theirs is this preposterous nonsense that the bullet has 2,000 of these magical watts, okay, that it can make the one atom going 1,000 miles an hour can do 1,000 times more work, more action, more stuff in the universe than the 1,000 atoms going 1 mile an hour. It's a nonsense theory on its face. They have the same capacity to move matter in the universe. There is no difference in their capacity, their absolute capacity to move material objects, to bang into them and push them, to exchange what they have with something else. They have the same capacity to make the exchange. Fuck. All right. However, imperfectly, by lamenting my own struggle, coming to grips with the concept of in an intuitively appealing way. So again, why would you even be worried about this intuitive crap, okay, when what you really want is a well thought out solution? Even though I can see in Michael's responses how the math all adds up, and I don't know how that works for you. 1/2 mv squared, a squared velocity makes sense to you. And how it's plausible in those terms. When I let all the math go and try to process it vicariously, something about it is like trying to grip a bar of soap. All there is, what there should be, is a pool of evidence. And you go where the evidence points. That's what the trial really should be dictated by, is the actual evidence. The first thing you should be able to say is physics as a science sucks because they don't produce evidence. They just tell stories. Okay, very narrowly contrived and configured stories. They tell you there's an evidence pool and that they've walked on its water. And if you actually go there, okay, it's just mirrors. All right. For example, what I said about joules per unit of fuel in my comment on Michael's follow-up video is just happens to be that you can't actually observe the fuel despite quadratically deplete quadratically with velocity. Again, it's fuel. You either need it or you don't need it, or you can play some game but that's impossible to play, frankly. The game that somehow, if you decrease your mass, you can now get more energy. Well, yes, that's true, but you have to decrease if you're going to go twice as fast, you're going to need to deplete your mass by at least twice as much, aren't you? So giving away a couple of milliounces of fuel isn't going to cut your mass in half and allow you to go twice as fast. Any idiot should be able to figure out that that's not going to be a fair exchange. You gave away a couple of million ounces of mass, and somehow now you can go twice as fast on the same energy? Well, of course you can't. So it's so implausible and crazy. And how it's plausible in those terms. Well, it's totally not plausible. It's not plausible that the fuel, the reduction in your mass from the absence of the use of the fuel cannot possibly cut your mass enough to make it possible for you to go twice as fast or 3 times as fast or 4 times as fast. It's not possible as a rational equation. When I all the math go and try to process it vicariously. Again, is that what he said? Something about bar soap. Okay, it always finds a way to slip my grip. Then the math comes along and it puts the bar back in my hand. So again, I don't understand why that would work for you. That these monstrosity equations they create, where they say something is equal to something else when they know it's only equal to something else once a day. Like it's 12 o'clock on the stopped clock. And so once a day, the two things match and are equal. But it's only once a day. The rest of the day, they don't come up with the same answer. The rest of the circumstances, they're not equal to each other. And they pretend they're equal. And they just take the formula that only works once a day, and they put it into the equation as if it equals the other thing. I mean, you think that's a good idea. For example, what I said about joules per unit fuel. Oh, I said that already, right? No, he's saying the same thing. In my comment, Michael's follow-up video. Didn't I? Yeah, I read this. So somewhere I made a mistake. You can't observe the fuel despite deplete non-proportionally. It just so happens to be proportional to change in. It just so happens to be proportional to the change in momentum. How convenient. Well, how convenient in the circumstance where how the fuck did you change the momentum enough, that is, change the mass so much that it's now going 3 times faster? How can you make something go 3 times faster by only changing its mass by a tiny fraction of a gram? It's not possible. Not only that, all the kinetic energy still tallies up according to theory. So, no, it doesn't, because of course it does. I don't know. No, just nonsense. I don't necessarily think KE is unsubstantiated. It has a lousy, rotten, stinking, disgustingly putrid bad history. And what does it have since then? Oh, that's right, no evidence at all. They can't even tell you how much fuel it takes to go twice as fast. They can't show you. I see there's disagreement about that. Yeah, duh. Okay, and I don't mean to suggest I have a stake in it. Well, again, you're suggesting that your only interest is to somehow say, oh yeah, there's a fight, but it's not about anything important, and there must be a semantical solution. Both people must be right. Some kind of horseshit like that. I'm only trying to rehearse the 101 stuff in my head as much as I can to squeeze as much understanding as I can out of it. What you have to squeeze is you have to recognize that this is serious physics. It's 200, 300, 400-year-old physics, and the fact that they haven't done anything to secure it with evidence should be an indicator right on its face that this is suspect science. When they've evaded doing the evidence, showing you the evidence, you got to say it's suspect. To be fair. Okay, so Dickhead says, okay, but at the same time, the way you speak, you make it sound like you're suspicious. So you believe KE is real? Question mark. So do you believe that gravity gives you 4 times, that gravity is a per foot force? Do you believe that? Because that's what Leibniz believed. Fuck. Like I said, I may not have articulated it well. It's hard for me to put my finger on. I'm just trying to understand how it relates to momentum. I'm not confident, as Draft clearly is, that something from 101 Chapter 3 is dead wrong. The momentum part is dead right. All the question I'm asking is what value does this fake assignment of joules have? Where does it show up anywhere? Where did Newton get a wrong answer? I mean, we're not talking about his guess about how fast something travels through glass or something. But, I mean, where does the momentum fail catastrophically? And the fact is you can't point to that place where it fails catastrophically except in these nuanced, silly experiments. Outside of nuanced, silly experiments, all the real world is saying, the professional bowlers are saying, there is no KE because I'm throwing the heavy ball. Because the lighter ball doesn't gain me anything. The wrecking ball companies know. I'm going with the big ball. It works better. All I know for sure is it seems challenging to interrogate. Whatever. But a little less so now that I've been thinking about it throughout the day. I'm convinced that work is, so this word work, which is mush, is necessarily taking place during a collision, which is a great point. It's a stupid point if you don't recognize that work can't be done by something that doesn't use its momentum. That a bowling pin can't make a pin move if it doesn't give away its momentum. Nothing can ever make something else move without losing its momentum. It's not possible to do it any other way. Alright, you said it's just so happens, but fuel has always been known to provide thrust or torque or some variant, not joules directly. So again, this is more baby talk. You're stating that joules are the thing, the watts. that it's making some kind of real energy, not fake energy. Joule isn't a fake thing. 1,000 watts is real heat energy. And with that thrust, the velocity and momentum increase linearly. So again, what does that even mean? Obviously, one of them increases exponentially. So there's no point. How can the KE, you know, and the thrust, the velocity and momentum increase linearly? Yeah, that's correct. That's what acceleration in linear increase in velocity. Right, so he's conceding that, yeah, it is only twice the velocity. So why do we think twice the velocity is 4 times the energy? Why do we think 3 times the velocity is 9 times the energy? Why do you think that? Where does it show itself to be true? It's not to be confused with the energy that builds as a thrust is applied over quadratically growing distance. So again, more of this nonsense about some sort of distance that's totally irrelevant. So it's just bullshit. I mean, it's the same momentum. The bullet and the gun have the same momentum. If you catch the bullet with the gun, it will move the gun the same as the recoil speed. That's all there is. There's just the momentum. Effectively proportional to the square of the velocity in accordance with the work energy theorem. Right, in accordance with a theorem for which there's no physical evidence of it actually being a truth. No one's ever collected this joules of energy bullshit. When you account for the mass to the propellant, when you account for the loss to the propellant, so again, more nonsense about how, oh, I changed the mass of the object by 4 millionths of a gram, and now it can go 3 times faster with the same energy. Everything adds up because this is how reality actually works, which is absolutely nonsense. It doesn't add up at all. It's just complete, contrived mathematical crap. It's not just a big coincidence. There's no coincidence. You have zero evidence and the logic is absent. Okay, you just weren't 100% clear about what these terms mean in their mathematical relation to each other. The subject was about relativity and whether it's a huge giveaway that if you start using 4 times the fuel to go twice as fast and 3 times the fuel to go 3 times as fast, that there's no chance that you're not going to be able to detect who's moving and who's not. Alright, so that's it for the comments on my video. Okay. My videos. Alright, so now I'll go find the ones on, it's already been a video in itself. Shit. Alright, well, I'll go do some of the stuff on the other video. Alright, back. Alright, so here's this tech guy's comment on Michael's video. Thanks again, Michael, for going out of your way. I'm impressed with how elegantly you've kept the math to a minimum, although the video was just all math. Although you've still given me a heavy dose of math to mull over, which I appreciate, and which I have to digest in segments at my own leisure. But I will say the concept of specific impulse, whatever the hell that is, all by itself seems to imply a rate of consumption of propellant can be proportional to the rate of change in the rocket's momentum. So again, how so? How is there an equal proportion between the speed of the crap leaving the spaceship and your mass, and therefore your velocity? You give away a tiny bit of mass, and somehow now you're going to be able to gain a huge amount of momentum. I had not really expected this, since I think the energy in terms of joules, and there's a concept called specific energy, which is the amount of energy joules per unit mass of fuel, which again are numbers always made up. Okay, so we know that you can do that calculation based on testing, I mean real tests, and see how many watts it actually produces, how much heat it actually produces. So I can explode a firecracker under water and I could find out exactly how much heat it creates in the water, and I could find the actual answer to how much energy it has. Or I can make a calculation and lie. Yeah. So, alright, later you apply calculus to conversion of momentum to illustrate this proportionality. So there's no proportionality. It's just absolute nonsense that because I lost 2 millionths of a gram of mass, that somehow now I'm able to go 3 times faster. That's not a proportionality in any sense. It definitely helps to consider that the energy dynamic isn't as simple as joules per propellant or joules per or joules in the rocket motion? Well, it just is that simple. It's how much pressure you can apply to two-cylinder walls, for example. So again, there's a certain amount of air pressure, CO2 pressure in a fire extinguisher. You can't make more, you can't make less out of it. It's the certain amount of pressure in the canister, period. That's all there is. It isn't more, it isn't less. And yes, you can inefficiently use it, but let's say you're in space, it's pretty hard to inefficiently use it. It's almost impossible to inefficiently use it. Okay, I'm convinced the math for kinetic energy works when looking at the whole system over any frame of reference. So he's convinced that the math for kinetic energy works. So all those other statements he made are just shit, because here he's just saying, yeah, it works, it's fine. I'm comfortable with the fact that the change in KE for each object depends on the frame of reference. So he's even okay with the idea that, well, even though you won't tell me directly whether it takes 4 times the fuel to go twice as fast, I'll just concede that even if it does, I don't care because relativity works. I mean, it's just such horse shit. And I can see how the dynamics of KE between objects can be nuanced. So, it's just a complete concession, basically saying I agree with everything you said, everything's just fine, never mind, you won. Now, did he say that on my video? No. So, I mean, it's just, sorry, this is just talking out of both sides of his stinking face. I mean, who needs more of that crap in the world? So, this crap we've already read, so let's get to the new ones. Alright, so I ask the simple questions, I get these crappy answers, okay, so I won't read my questions again, but because they might be in the answers. Alright, so we left off here, so here's the last response video, which I don't even think the other guy, tech guy, has even seen. Anyway, so Chris Moore is apparently White Henry, okay. So he had a chicken, whatever, so we won't bother with that. Okay, so it's a silly name because you named your channel after your chicken. Okay, got it. If I accelerate a car from 0 to 10 miles an hour, do I use the same amount of gasoline to accelerate from 10 to 20 and that I use from 0 to 10? Do I use the same amount of gasoline to go from 90 to 100? So he says no. Okay, so he's conceding that you have to use more fuel, which again breaks the relativity argument. All right, but he's not going to say it with any more authority than anybody else who's saying it. He's not going to be able to show us any evidence. If it takes 1 unit, I think he meant here, it says until, to go from 0 to 10, it takes 3, okay, units to go from 10 to 20. It takes 3 more, okay. It takes a total of 4. And 19 units to go from 90 to 100. 19 more. Okay, it actually takes 40. 40 more. I mean 40 total. Something like that. Well, whatever. I haven't figured it out. It's different for rockets. In rockets, it takes the same fuel to go from X to X plus 10 independent of X. So he's saying that somehow there's this difference in the physical universe, that somehow the same thrust, you could do it with the same idea of just using thrust, just using air pressure, for example, that on Earth the air pressure will give you, okay, you have to use 3 times the air pressure to go, you have to use 9 times to go 3 times faster. All of that's true, but it isn't true in space. So again, it doesn't make any sense, frankly. I don't think that's a non-starter, I think, to say that the rules in space are different than the rules on Earth, because the only thing that changes between the two circumstances is the nuisance of an atmosphere. Really, it's about it. Both of these are ignoring wind resistance, inefficiencies in the method of propulsion, etc. Well, yes, so if you're ignoring air resistance, then how is the Earth any different? Oh, okay, so he's saying you're pushing against the road. In the car, you are pushing against the road. I would argue you're really not. The road is completely pushing back. So the road is just rejecting. So where you're not hurting the road, that is knocking pieces off of it, the rest of it is just the road saying, fuck you, I'm not moving. The road's an immovable object. You're banging your your wheel against an immovable object, the wheel is bouncing off, which is moving faster relative to the car. The faster you go, in the rocket you are pushing against the front of the combustion chamber. You're not pushing against it, frankly. You're letting go of stuff that would have pushed against the opposite side of the combustion chamber. You have a combustion chamber, you still have stuff hitting this wall. You've poked a hole in this wall and you're letting it out. So you now have more stuff pushing this way than you have stuff pushing that way. Which is always moving the same speed, not at all relative to the rocket, no matter how fast you go. Not at all relative to the rocket, no matter how fast you go. The rocket and the combustion chamber are traveling together, so I don't even know how that could make sense. So he's question 2. So we have no proof or evidence, no citation to an experiment, nothing to defend his position besides White Henry says so. Chris Moore says so. All right. Do you believe springs compressed twice as much can release 4 times the energy of the half compression? Yes, it takes 4 times the work to compress it twice the distance. So we know it doesn't take twice the work. That in fact, I can do an event, compress a spring 1 amount, and all I have to do is add the same event and it'll compress twice as much. That's exactly what gravity does. I add a weight, 5 pounds, okay, and I just add another 5 pounds to make 10 pounds. 10 pounds is twice the compression. Both weights are sharing in the duty. The second amount of compression was done with the addition of exactly the same amount of force. So it's only 2 units of force. I can't get 4 units of force out. And it can be released 4 times the energy too. So that's he says. There's absolutely no factual evidence to prove it. Blah, blah, blah. Do you believe that the same amount of explosive can create different amounts of total momentum disregarding direction? No. So he's saying no to physics Michael's experiment. And, pretty much conceding that that doesn't make any sense. So that's good of him. Total momentum cannot be created. That's right. And you can't make other things happen without using your momentum. You can't make heat go somewhere and it's still going there, right? You can make heat and then make it come back in again and give it back to itself, right? You can have waste energy that comes back and helps you, but you can't, if it's still going, if you let the heat go into space or something, you can't use that energy a second time. It's gone, and the only way you created it was to use something's momentum. All right, that's what the law of conservation of momentum is all about. Explosions create momentum. Well, you say so. You know what they say? I know what he's going to probably say anyway. Is that it's zero momentum. As of course it's not. It makes a difference. If I have 2 experiments, in one experiment I do the same explosion. In one experiment I get 400 momentums. The other one I only get 100. That's a gigantic difference. That's not conserving the momentum. What went wrong? I mean, you've got to account for that wrong. You got to account for the experiment he did. Okay. Explosions create momentum in multiple directions. Exactly. So I said regardless of direction right there, disregarding direction. I think all momentum is momentum. There's no such thing as anti-momentum or unmomentum or whatever, free momentum. There's no such thing as anything but real momentums. All momentums are real. Bullet going this way, real. Bullet going that way, real. There's no unreal canceling out momentums. But when you sum those momentums up to get the total momentum of 0. So again, it's just nonsense. Explosions don't make 0 momentum. It's just absolute fucking nonsense to argue that explosions make 0 momentum. It's so ridiculously stupid, I couldn't even blame it on a retarded 10-year-old. It's so ludicrous a starting position. I'm going to talk sensible about the world and how it works. And guess what? A really sensible way to understand it is explosions don't make any momentum. The sun doesn't make any photons because it sends photons the opposite way and they canceled out. It's not real energy. The sun didn't make any energy, didn't use any energy, didn't make any energy, didn't do anything. Nothing really happened here. I mean, it's just ridiculous a starting point. if you for some reason want to sum the absolution values, because that was supposed to be absolute, of the momentum, ignoring the direction, yes, that's exactly what I said, then yes, the total can be different depending on the masses. So he's defending some notion that, I can take the same exact explosion with the same little particles flying off of it, and that somehow I can make those little particles give more momentum or less momentum. I just change the mass, and I can change how much movement power I have created in the universe. I'd say that's absolute nonsense. The total KE will be the same though, so they're conserving the KE, which is the nonsense bit, the 2,000 joules in the bullet, they're saying those are real, and the 2 joules in the gun, and that makes sense somehow. They're conserving the KE somehow. Oh no, I guess they don't have to conserve it. This is what we see from physicist Michael experiment with launching carts at different masses from compressed springs. Yes, exactly. We see something that frankly doesn't make much sense. That the same spring compression made different amounts of momentum. The same exact spring compression, uncompressed, makes different amounts of movement in the universe. That seems preposterously silly to me. Okay, different individual amounts of momentum which sum to 0, but the same amount of KE. So again, if this were true, then guns wouldn't work. What he's basically saying, if I put 2 bullets in a zip gun with the explosion, the bullets won't move at all. The only way I can make the bullet fly out of the gun is I have to have one side sealed, and then the bullet will fly, because then the force will go into the recoil of the gun. So the recoiling gun works. But if I made a zip gun and shot both 2 bullets, no, it wouldn't work at all. The bullets would just fall, bleh, bleh, they just bleh out of the gun. Yeah, bullshit. Okay, so White Henry. So same guy. I want to clarify something, see whether you agree with me or not. So let's see. So that's the other guy he's going to agree with. I follow your logic, and it does appear that the change in total KE is proportional to the square of the change in the rocket's velocity. Change in the KE is proportional to the change in the rocket's velocity. Obviously, what sense can that make? The KE is exponentially growing. So what does proportional mean? So that doesn't mean anything. It doesn't make any sense to me how it could be. If one jab on the booster button gives 1 unit of velocity increase, another jab gives just another 1 unit of velocity increase, how can 2 jabs give us 4 times the KE? 2 jabs, 2 increases would be 2 times the fuel, surely. I've had 300 years to figure this out, and I still don't get it. So I don't even understand this comment. He was so assertive here, and now he's so, well, maybe you're right. So Watto is, Farley, so maybe there's no point in even reading this. The difference between 1 big jab and 2 small jabs, again, more nonsense. That wasn't the comparison. Is that the 2 jabs cause you are moving delta M fuel forward in the first jab, which is useless work. Of course it's not useless. Your total momentum is decided by your total mass moving. So any part of your mass that has stored the energy by moving. So you have stored energy in moving the fuel tank. That's part of your energy storage. The moral of the story is that the best case would be to burn up all the fuel in a big thrust at the beginning rather than carry the fuel with the ship. You can't lose the momentum that you've gained from the tank's movement unless you hit something. So it obviously isn't hurting you any if you want to have momentum when you're going somewhere. Obviously humans would have trouble handling the acceleration, but might work for moving cargo. So again, it's just made up mush about some scenario. The force that you're fighting is gravity, and that's the only thing that matters. And the fact is that yes, obviously, if you don't need to, it's always better to burn the fuel, because it's always a benefit not to carry it. Okay, so not to have to push it. but we're not fighting a force. So part of the argument is that in that case, it can't hurt you much if there's no resisting force. Because you just keep decreasing the fuel over time, and every decrease in the fuel will gain you not only the fuel power, but the fact that you're letting go of a piece of matter that you were in fact pushing that way, or moving that way, or have pushed that way. Let's see, so there are some comments to this last, let's see, oh, that's the inaccuracy thing, so I already did that. Okay, good, I made it through this. So curiously, no comments by physicist Michael to any of this tripe in the last couple of days. His last comment was 2 days ago, I guess. So he hasn't responded to anything at all regarding the questions I asked anyway. And that's where we stand. And we're still waiting on the lever experiment and blah, 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 blah. So, yeah, it doesn't look like there's anything new. Alright, so that's enough of a video, I believe. Yeah, it's enough. An hour is enough. Just make sure nothing else came up. No, that's enough.